Hi, I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University. In this screencast today, we're going to cover the handout that I provide for elementary physical chemistry, Chem 343, the online version. So I often will call this Pchem Cloud Lab. And because a lot of our online laboratories have computational components, have remote and automated experimental components, and have data science components, we'll often call this overarching things projects instead of individual exercises of or laboratories. And the goal is really to use to show students modern remote access and cloud lab services, which are a huge growing part of the modern chemical and biochemical laboratory and ways of doing laboratory molecular sciences. So I discussed that a little bit in this first handout because this will often be the first time students are taking a lab that have this kind of cloud lab or remote lab type component associated with it as an emphasis. So this, we're specifically talking about online physical chemistry, which is at ASU, is Chem 343. It's the fall 2021 semester. And this is the handout that I've made. I put it in a similar format to what I would expect students to have as far as lab reports, where the sections are obviously a little different. So I provide some of the objective of this, which is 341. The lab is meant to correlate to some of the physical chemistry lecture material, and what's mainly covered is the molecular thermodynamics, and then towards the end of the semester, some kinetics and maybe a little spectroscopy. But a large part of the emphasis is molecular thermodynamics, and in large part that often starts with looking at the properties of gases. And so we'll start project one with a lab in this vein. So I, of course, give some background material, and here, like I said, I often give a little more background material because of kind of the novel new development of using this type of cloud lab experience at the undergrad level. And so I talk a little about that, where most of the time for future labs, it's really just providing an introductory to the material that's going to be covered, and appropriate reviews, citations, books, journal articles, etc., where background material and introductory material can be found. So it's not meant to be an exhaustive review of that, but more a resource where if students need specific introductory or background material, they will have this handout as a resource to give them the citations and allow them to find what their need in that category. And then, of course, the intro tries to summarize what they'll be doing. As I've said, all of these will have a computational component. It will have a direct experimental, so a cloud lab or a remote lab experimental. Some also have kind of a do-it-yourself at home optional component as well, even though the emphasis here is really on remote access to instrumentation, to advanced instrumentation, where students are able to remotely control, remotely collect data, and access their data and be able to bring it back to process it. And so the last part of having that is you have both this computational data, which is typically collected off of online off of computer clusters, etc. So some of the research computing clusters at Arizona State University. The experimental is having access to some of our advanced instrumentation that you can access remotely, control remotely, run in automated modes or remote manual modes, etc., to collect some of this data. And then finally, to take that data And this is often done, while there are resources to be able to analyze it remotely, this is often where you get the data and analyze it on your own local system. So a data science component, which is mainly made up of data processing and analysis and error analysis associated with both the computational and experimental components of this. And so I try to provide kind of all three sections and kind of a bulleted list of what we're going to be doing in each of those sections, overview. And then finally, extensive references, because these physical chemistry projects are ones that are very well documented in books, in laboratory manuals, in journal articles, in the Journal of Chemical Education, and American Physics, etc. So I provide numerous citations of where this material come from and where some of the inspiration and stuff is for doing a lot of these labs for physical chemistry, to give students that experimental expertise on things that have broad-reaching applicability in all areas of chemistry, biochemistry, and the molecular sciences for the future. So hopefully this overview helped, and I look forward to interacting with students during this Pchem Cloud Lab. Thank you.